You are looking at a $7 kit sitting inside a metal cookie tin, 2 automotive relays, and a fuse set from any auto parts store. That combination, stored on a shelf in your garage, is the same solution the US military uses to keep vehicle fleets operational in EMP threat environments. And if you think you know what an EMP actually does to a modern car, the answer, the government tested, is almost certainly not what you think it is. Your car right now has between 50 and 100 microprocessors. They control your fuel injection, your ignition timing, your braking, your transmission, your steering assist. Every single one of those processors is connected by wire. And every wire running through your vehicle is, by the laws of physics, functioning as an antenna. An electromagnetic pulse, the kind generated by a high-altitude nuclear detonation, arrives in 3 distinct waves. The first wave, called E1, delivers its energy in approximately 3 nanoseconds. For reference, a nanosecond is 1/billionth of a second. The fastest automotive circuit protection available responds in approximately 1 microsecond. That is 1,000 times slower than the pulse that just fried your ignition computer. No surge suppressor, no matter what the box says, can respond to a 3 nanosecond event. The physics do not allow it. And here is the thing that changes how you think about the $7. The reason EMP destroys modern electronics is not complicated once you see it. A nuclear EMP generates a massive electromagnetic field propagating at the speed of light. Every conductor within that field, every wire, every cable, every trace on every circuit board, collects energy from that field and converts it into electrical current. The longer the wire, the more energy it collects. The more modern the chip it connects to, the smaller the current spike needed to destroy it permanently. Your car has hundreds of feet of wiring. Most of it feeds directly into processors with extremely low tolerance for unexpected current. When E1 arrives, your wiring harness becomes a collection antenna feeding a surge into every control module simultaneously. The US EMP Commission tested 37 vehicles in a controlled facility in Colorado. Most stalled. Some required a momentary battery disconnect to reboot. One truck had to be towed and never restarted. And not one of those vehicles had a single component inside it designed to resist what just happened. What that test did not measure is what happens when the pulse is larger than the simulator's maximum output. Before 1975, ignition systems in American vehicles ran on points and condensers, a mechanical contact that opened and closed to fire the spark plugs. No chips, no processors, no semiconductor components anywhere in the drivetrain. An engine running on a points ignition is not vulnerable to EMP because there are no circuits to destroy. The mechanical components that move fuel and air through the engine are completely unaffected by electromagnetic fields. Pre-1975 vehicles are as close to EMP immune as a gasoline-powered machine can get. The 1975 Clean Air Act changed this. Manufacturers needed to meet emissions targets that mechanical carburetors could not achieve with the required precision. Electronic ignition arrived first, then electronic fuel injection, then the first generation of engine control units in the late 1970s. By 1990, virtually every car sold in the United States had a management computer that could be permanently destroyed by a strong enough E1 pulse. 50 years of engineering progress created 50 years of vulnerability. Not one line in any owner's manual mentions it. Here's the detail that changes what the $7 actually buys you. You cannot protect the electronics in a modern car from E1 without enclosing the entire vehicle in a sealed conductive Faraday cage. No gaps, no openings, no external wires. That is the physics requirement for full protection. Nothing short of full enclosure prevents an E1 pulse from reaching the chips inside a running vehicle. You cannot put your car in a Faraday cage, but you can put the replacement parts in one. That is the entire difference between being permanently stranded and being back on the road in under an hour. Military vehicle maintenance units do not attempt to protect their vehicles from EMP in the field. They protect the spare components. The vehicle gets hit. The spare parts survive. The vehicle gets fixed. The components most likely to fail non-recoverably are specific and predictable. The ignition relay, the fuel pump relay, the crankshaft position sensor. In older vehicles with fewer computers, those 3 parts are the entire repair. Here's why the relays come first. Your engine control unit does not receive power unless the ignition relay is intact. Your fuel pump does not run unless the fuel pump relay is intact. Without both of those relays functioning correctly, the engine will not start regardless of the condition of everything else. 2 relays, located in the fuse box, under your hood, or under your dash, depending on the vehicle. Replacement cost for the pair runs between $3 and $7 at any AutoZone, O'Reilly, or online through RockAuto. Your specific relay part numbers are stamped directly on the relay housing itself, matched to the diagram on the inside of your fuse box cover. This is the $7. 2 relays. a fuse replacement set, into a metal container. The container matters more than anything in this kit. Find a metal tin with a metal lid, not plastic body with a metal lid, not a metal body with a plastic hinge or a plastic latch. Entirely metal, completely enclosed when shut. A metal cookie tin from any dollar store works. A metal coffee can with a steel lid works. A military surplus ammunition can, a standard .50 caliber ammo can runs about $14, provides genuine Faraday shielding that meets documented military specification. The lining is the one step most people miss. Any parts stored inside must not make direct contact with the metal walls. If a component bridges from the contents to the outer shell, any energy the shell collects transfers directly into the part you were trying to protect. Line the inside with a folded paper towel, a piece of cardboard, or a foam sheet. Electrical isolation between the contents and the container walls is what makes the tin a Faraday enclosure instead of just a storage box. Place both relays inside. Add a full fuse kit for your vehicle, $3 to $5, and covers every fuse your car uses. Close the lid completely. Mark the outside with your vehicle, year, make, and model. Store it in your garage, not in the car. Any parts sitting inside the vehicle at the time of an event are exposed to exactly the same pulse that just damaged the vehicle. After any EMP event, open the hood, locate the fuse box, swap both relays from the tin into the matching sockets in the fuse box, replace any visibly burned fuses, reconnect the battery. That sequence takes under 15 minutes. Most people will not know it is possible. Here is the piece of this that belongs in a different conversation entirely. The Carrington event of 1859 was not a weapon. It was a solar storm, a coronal mass ejection that generated a field strong enough to set telegraph lines on fire across North America. Telegraph operators reported electrical shocks through equipment hours after they had disconnected the power supply. The induced current in the bare wire was that strong. A repeat of the Carrington event today would not destroy your car's ECU directly. Solar EMPs do not produce the E, one component that fries small electronics. What a repeat would do is take down the high voltage transformer infrastructure that runs the national grid. The National Academy of Sciences estimated restoration at 4 to 10 years. Within 72 hours, every electric pump at every gas station in the affected region stops working. Your ECU may survive the event, the fuel supply chain will not. The relay kit in the tin covers the detonation scenario. The fuel scenario requires an entirely different prep and an entirely different $7. Total kit: 1 metal tin, 2 relays, 1 fuse set. Under $15. Built in 20 minutes. Relay and fuse diagrams for every make and model are linked in the description. Find yours, pull the part numbers off the relay housing, and order the spares before you need them. If you learned something today that you did not know before, subscribe. And share this with someone who drives a modern car and has never once thought about what happens to it if the grid goes down. That share might be the most useful thing either of you does this month.